All right, guys, just to remind you, remember we're in a unit called nomenclature, which is a system of naming, and we're naming basic binary compounds. And as you might expect, binary is a combination of two things from your valence sheet. So you'll always be referring to that valence sheet, which is in the material section of your Google Classroom. So here are the possible combinations that we're looking at this unit. The last video lesson, we went over a metal-non-metal combination, and then we went over a metal polyatomic ion combination, and then we're going to go over the last two today, which are acids, which is a combination of two things, which we're going to show you here briefly, and a combination of two nonmetals. And the reason why it's important to know, to first determine what category your compound is in, is because remember, each specific category has its own unique naming rules that you're going to apply in order to name it correctly. So let's go into acids. So acids, here is the combination. You guys, what's common to all acids? They all have this hydrogen, which ultimately can dissociate from it, but we're not going to worry about that yet. We're just doing, focusing on naming these. So once you determine it's an acid, the easiest way to determine if it's an acid, if it begins with a hydrogen, it's going to typically have a hydrogen in the front of the formula. Then you're going to have to make a further distinction. Is that hydrogen bound to a nonmetal, right? We're talking like chlorine, fluorine, bromine, or iodine, or is that hydrogen bound to a PAI? Remember, PAI is a polyatomic ion. That's multiple atoms together. The reason why you're going to have to make that distinction, as you might guess, there are actually slightly different rules that you use depending on what it's bound to. So here's the rule for if the hydrogen is bound to a nonmetal. Okay, the rule is your name starts with hydro. You name the nonmetal. However, you change the end to ic, and then you put acid on the end. Okay? So practicing. So here it's HCl. I'm like, okay. You guys remember, you always want to first go, okay, combination of two things. Oh, hydrogen is, okay, it's hydrogen, and it's bound to a nonmetal. Oh, it starts with hydrogen. Oh, it's an acid. It's bound to a nonmetal. Oh, I apply this rule. So apply that rule, guys. Give you guys a few seconds. What do you think you'd call HCl? You guys got it correctly. It would be called hydrochloric acid. By the way, guys, that's the acid in your stomach that your body uses to help digest the food that you eat. Okay, now look in this case. Here's now a rule if their acid is with a polyatomic ion. So once again, you guys are given a formula, come a test. You want to identify what it is. You first have to break it up into two things. So you look at it and you're like, okay, what two things look familiar on the valence sheet? You guys should recognize, oh, it's a hydrogen, and then NO3 looks familiar, hydrogen, H and NO2. So you go, oh, it begins with hydrogen, oh, it's an acid, then, oh, it's an acid with a polyatomic ion. You guys see why it's called polyatomic, more than one type of atom bound together. So now you're gonna apply the rule. Here's the rule. Oh, just to remind you guys, remember when it was with, don't write it down because you already seen this. Remember when it was with a nonmetal, you did hydro and then changed it into an acid. But with this, when it's with a polyatomic ion, you don't use hydro. You guys, that's the key thing. Hydro is not used. And here's the rule. You put the polyatomic ion, however you change the end to ic. Oh, for example, if your polyatomic ion, NO3 is nitrate, so if it ends in ate, you change it to ic and you have acid. If your polyatomic ion ends in ite, NO2, you guys look on your valence sheet, that's called nitrite. So if it ends in ite, you change the end to us. That being said, what would HNO3 be called? Nitric acid. And what would HNO2 be called? Nitrous acid. So you're applying these rules, so you guys should be writing this down, okay? So let's look here. I think you guys, right, once again, we break it up into two things. What two things look familiar here? Oh, H and SO4, H and SO3. Somebody might say, Mr. Wilson, where did that 2 come from, right? You guys, just like the previous categories, the total valence of all the substances in these compounds has to equal 0. So the reason where that comes from is, you guys see sulfate is -2 here, and so if hydrogen's +1, I need 2 +1s to balance with that -2. Okay. So you guys look. Starts with a hydrogen, you're like, oh, that's an acid. And you're like, okay, oh, and it's with a polyatomic ion. Oh, so I'm not gonna use hydro. I'm not gonna use hydro. I'm gonna name the polyatomic ion, SO4, I look on my valence sheet, oh, that's called sulfate. Oh, what does the rule say? Oh, change the ate to ic. So you're thinking, right, sulfic acid, and then SO3, that's sulfite. The rule says change the end to us, O-U-S, sulfus acid. Now, if you guys put sulfic acid and sulfus acid, I would give it to you correctly. But for phonetic reasons, that just means that chemists realize it sounds better if you say, and you guys might have heard this, this is actually the most produced chemical in the United States. It's not called sulfic acid, it's called sulfuric acid. And this is not sulfus, but sulfurous. If you guys didn't add that slight little add-on, don't worry, I'm not going to penalize you for that. All right, so now going back. Now we're going to go in reverse. Well, actually, we're not going in reverse. Oh, this is just kind of a little practice. Okay, so first of all, it says they're all acids. How do we know? How do we know these are both acids? Yep, a hydrogen in front. Then on this one, let's look. Now it says, okay, which are the acids with nonmetals? Which one of those has just a nonmetal? Hopefully you guys would recognize it's this one. So then you would proceed to name it. So, you guys remember what the nonmetal? Give you guys a few seconds. Remember, what does it start with? It is called hydroiodic acid. Remember, the rule says add hydro. This is iodine. Change the N to ic, hydroiodic acid. Now this one, right, you're not going to name it the same way. It has different rules because this is an acid with a polyatomic ion. So remember, the rule is you don't add hydro, so it's not going to start with hydro. This is carbonate. If you look on your valence sheet, it's called carbonate. The rule says, oh, if it ends at 8, I changed it to ic. So what's this called? Carbonic acid. Notice there's no hydro. Carbonic acid. By the way, guys, this is the acid that formed when carbon dioxide, you have carbon dioxide in the air. If you guys leave like a glass of water overnight, it's going to absorb some carbon dioxide from the air. That carbon dioxide is actually changes slightly into carbonic acid. And so if you drink your water, if you leave it sit for several hours, it probably will taste slightly different than when it was initially due to the buildup of carbonic acid in that water. It says, wow, you're actually calling someone on Facebook a big idiot? He's like, too harsh? That'd be kind of harsh, right? Well, you should probably add a smiley face. Yeah, and maybe an LOL, right? Because if you add a smiley face, then it's all good, right? All right, so you guys, we got to go in reverse. Now here, given the name, we got to get the formula, okay? So, first thing is you want to identify what type of compound it is. Obviously, these are both acids because obviously we're talking about acids today, but how would you know on a test when I have all these different binary compounds intermixed? How would you guys know they're acids? Come on now. Duh, because it says acid on it. So that we know they're acids. So you think about it, guys, what are you going to start your the formula with? When you start it with an H. So I'm going to start it with an H. Now, on this one, guys, look. So look, now this starts with hydro, so I know that this has to refer to a nonmetal. What's the nonmetal fluoric refers to? As you guys would guess, look on your periodic table. It's probably referring to fluorine. So yeah, nonmetal. So it's referring to fluorine, so I'm going to put F. The last thing but you guys got to remember, you always have to check the valence. Remember, the total valence has to equal 0. So I look at this. Hydrogen, on your valence sheet, you'll see it's a +1. You guys should know fluorine is the halogens. The halogens tend to gain 1 electron. They always have a valence of -1. You guys look, equals 0. I don't have to add subscripts. Those combine in a 1-to-1 ratio. That's fine as it is. Now, phosphoric acid. Now I got to think, okay, what am I going to put here? Now you guys got to remember, there's no hydro, so this must mean it's referring to a polyatomic ion. You guys see why this is important? Because if you didn't recognize that, you might think phosphoric is just referring to phosphorus, and you'd put a P there, and you'd be wrong, right? It's not referring to the nonmetal phosphorus, it's referring to the polyatomic ion. Remember, if it ends in ic, that means it came from a polyatomic ion that ended in 8. I look at my valence sheet, because I don't expect you guys to memorize this at this point, and I'm finding, oh, it's phosphate, and phosphate is PO4. Last thing I gotta do is check valences. You guys, phosphate has a -3 valence. If hydrogen is +1, you think about it, guys, do I need more phosphates or do I need more hydrogens? When you guys agree you need more hydrogens, how many total hydrogens, if hydrogen is +1, would you need to balance with phosphate, which is a -3? Hopefully you guys realize you would need 3 of them. It's H3PO4. By the way, guys, this phosphoric acid is actually an ingredient. You look on Coca-Cola, Coke can, it'll be like maybe the 6th or 7th ingredient. And you think about why would they add acid to the soda. Why do they add anything to soda and a lot of things that you buy? It's all for taste. It kind of gives it maybe just a twang, or is it twang or tang or whatever the kind of effect that a little bit of acid would add. Okay, so you guys put a break in your notes. Now completely different, last category. Now we're doing two nonmetals. So we did acids, put a big break in your notes. Now two nonmetals. Those are going to have completely different rules. Okay. Guys see that little water heater right there? All right. So, so you guys see now we're at the last category, two nonmetals. Now you guys will notice this, for the first three, the total valence has to equal 0. Now there's a reason why that rule here does not apply to the second, or to the last category. Okay, so look, so these are just the examples. So this is a two nonmetals. Okay, so how do you know? What you do, what you always do is, remember, break it up into two things. So I break them up into two things, and then what do I recognize? Well, I look at the two, I'm like, oh, there's only two elements. And you know what? If you look on the valence sheet, where will you see sulfur and oxygen, nitrogen, oxygen, nitrogen, oxygen, sulfur? You're going to see them on the bottom. And what do you notice on the bottom? They're all negative values. So you see that they're both nonmetals, and they're because they have negative values. Or you know what? You'd see there's only two elements, and you see where they're located. They're all located on the right side of the periodic table. So that must mean they're nonmetals. Okay. So when you have that case, now you notice. Look at here. It says the total valence does not equal 0. You guys remember why that is? Well, if they're nonmetals, they both have negative valences. Can you ever sum up negative values and get 0? You can't. So that rule does not apply to two nonmetals. Okay. So, you guys, this is the one category where we're going to use prefixes. Okay. So here are the prefixes. I think a lot of you guys might know. The prefix for one is mono. Maybe you didn't know that. 2, di. 3, you guys should know 3, tri. 4, remember, 4 was tetra. 5, penta. 6, hexa. 7, hepta. 8, octa. 9, 9's kind of tough. Think about maybe your what you might call your grandma, nana. And then 10, you guys think about 10. Think about 10 years. How long is 10 years? A decade. 10 is deca. So some of these you guys already know. Maybe there's one or two that you don't. Either way, you guys list them. So those are the prefixes that we're going to use in our rule naming steps. Okay. So here they're still there. Okay. So here are the rules, guys. So put this down. So the rule is on the first nonmetal, it says you use the prefix if, and you guys know if you have an arrow pointing to the right, that means more than. If you have more than one, you use a prefix here. And then on the second one, notice it says on the second nonmetal, it says you always use the prefix on the second one regardless, and you change the end to I. Okay, that's the rules, guys. So that being said, we're going to practice. So on the first one, what am I going to put? I'm going to put sulfur. Notice I didn't put a prefix. Why don't I put a prefix? Because there's only one. Okay, you guys see that there's one. And then the second one, I always use a prefix. Notice, look, how many oxygens do I have? I have 2, so what's the prefix? I'm going to use di. It's oxygen. I'm going to call it diox, but then you change the end to I, it's going to be sulfur dioxide. You guys, this is the gas that's often produced in industry. Whenever you see big factories and like a lot of smoke and stuff that's coming out of the factory, a lot of times it's sulfur dioxide. The problem with that is the sulfur dioxide can build up in the atmosphere and then collect in the clouds and then dissolve in the clouds, and then when it precipitates, when it rains, you're going to have acid rain, which is a dilute sulfuric acid, which comes as a result of the sulfur dioxide dissolving in the moisture of the clouds. But anyways, okay, next one. Okay, first one, am I going to use a prefix? No, I'm not going to use a prefix because there's only one. Okay, and the second one, you always use a prefix. So there's one of those. So what's the prefix for one? Oh, it's mono. So I'm going to call it mono, and it's oxygen. Somebody might think it's like monoxide or monoxide, but you guys know for phonetic reasons. Now, if you guys didn't do this, I'm not going to mark you wrong, but we typically remove one of those O's, and it's going to be called monoxide. Right? It just sounds better than monoxide or monoxide. It's just called monoxide. Okay, next one. How we're going to begin the name? You guys should know. We're going to begin with a prefix. Why are we going to begin with a prefix here? Oh, because I do have more than one. There's two of them, so I have to start with di. The non-metal is nitrogen, so it's dinitrogen. The second one, I always use a prefix. There's 5 of those. The prefix for 5 is penta. Penta, call it pentaoxide, but you guys probably already know what you're going to do. You're not going to call it pentaoxide. What are you going to call it? Pentoxide. Take off the A. If you didn't take off the A, don't worry. I'm not going to mark you wrong on that. Okay, SF6. I'm not going to use the prefix, right? Because there's only one. So it's sulfur, and then it's fluorine, but there's 6 of them. 6 is hexa, so I use this hexa on the last one. It's sulfur hexafluoride. He says, well, hello there. He's picking the girl up. He's saying, I can still see you. So yeah, unfortunately, ladies, that's not going to help you avoid creepy guys. Sorry. All right. Carbon tetrachloride. So hopefully you guys can see that. No, it's probably not good, not a color font, but so once again, so now we're going to go from the name to the formula. We're almost done here, guys. Always, always, always determine the category. Obviously, we're talking about 2 nonmetals because that's our category we're talking about, but you guys are going to have to be able to figure it out on a test. So my question would be, how would you know that this compound here is referring to a 2 nonmetal combination? You guys should know. You're looking for, oh, it's got a prefix. It's got one of those prefixes that sounds familiar to me. Remember, you only use the prefixes when you have a 2 nonmetal combination. So it's 2 nonmetals. So now that's going to be easy. So now I'm going to just put carbon, which is what? C. Tetrachloride. Well, what's the nonmetal it's referring to? Chloride. Oh, that's referring to chlorine. Well, how many chlorines do I have? Tetra is the prefix for 4. It's CCl4. Guys, I think a lot of people find that the 2 nonmetal ones is the easier one. You don't have to worry about valences or anything like that. In the name, it'll tell you what the subscripts are. Look at sulfur trioxide. Okay, so sulfur, I'm going to put, right, the prefix tells us it's 2 nonmetals. Sulfur is an S. Trioxide, that's referring to oxygen. I put an O. How many oxygens? 3, it's SO3. Somebody said, oh, that looks like sulfite from your valence sheet. The difference is, guys, in this case, this doesn't have a valence. Remember, these are neutral compounds. It's a combination of 2 things. On your valence sheet, sulfite, it looks the same, but you guys, it has a valence. You remember the polyatomic ions always combine either with a metal or with hydrogen. So that's kind of the difference. So this is sulfite polyatomic ion. So it has a charge. And this is sulfur trioxide, a neutral compound. Okay, guys, so that is all 4 of our categories. Hopefully you guys are going to practice those and be ready for to rock and roll. All right, guys, we'll see you.